Good morning, Math A. We are going to do lesson 6.2b, scaling triangles. So hopefully you have out your PDF or your lined piece of paper, or you're doing it digitally. Anyways, follow along the lesson as we go through it. All right, let's revisit triangle ABC and PQR from the previous lesson. So this was in 6.2a. For numbers 1 through 8, use a figure to the right to write each ratio as a fraction in simplest form. Okay, so it says BC to QR. So I find BC, it's a 2. And I find QR, it's a 6. And I write it as a ratio. BC has to come first. So 2, 2, 6. And then I reduce it. That's going to be 1, 2, 3. So go ahead and try number 2 through 9. Pause the video, do 2 through 9, and then come back and check. All right, so on number 2, I got 1/3. On number 3, I forgot to reduce. I should have still got 1/3. On number 4, I didn't actually go find the perimeters. I remembered that my scale factor is the same as my perimeter ratio. So if I knew my scale factor was 1 to 3, I automatically know my perimeter ratio is going to be 1 to 3. Now, I could have found the perimeters. It wouldn't have been wrong. 15 to 45. That would have reduced down to 1, 2, 3. Number 5, I got 2 to 7. Number 6, I got 6 to 7. Number 7, I got 3 to 1. Number 18, I got 3 to 1. Okay, number 9. Some of the ratios above make comparison measurements of the same triangle, while others make comparison measurements of corresponding parts of 2 different triangles. Put a star by the ratios that compare 2 different triangles. What do you notice? Okay, so I have to go back up and look. I know number 1 is comparing 2 different triangles. Number 2 is comparing 2 different triangles. It comes down to 1/3. Number 3 is comparing 2 different triangles. It also comes down to 1/3. Number 4 is comparing 2 different triangles. It's also coming down to 1/3. So all my comparisons of the 2 different triangles, as long as I did the smaller triangle on top and the bigger one on the bottom, they all came down to 1/3. So I'm going to write that in. All right. Okay, so we have ratio and scale factor, and these two terms get mixed up a lot. So we have to pay attention to what's happening in a ratio and a scale factor. A ratio we can write as A over B, or A colon B, or A to B. But it's comparing the 2 triangles. So if I said the ratio of ABC to PQR, I'm putting triangle ABC on the top and triangle PQR on the bottom. And I'm saying, hey, ABC would have a 1, and whatever's on PQR is 3 times bigger. So the ratio between ABC and PQR is 1 to 3. A scale factor says when you go from ABC and you go to PQR, we want to know what are we multiplying by. So we're going from the smaller triangle to the bigger triangle. So here the scale factor would just be a 3. So we have to really pay attention. Did it say ratio or it did say scale factor? Because those are 2 very different things. So we saw in the last example I just did, the ratio of the little to the big was 1/3. But the scale factor from the little to the big is 3. Okay, so they're reciprocals of each other. We have to pay attention to that. Since the corresponding parts have the same ratio, their scale factor from triangle ABC to triangle PQR. The scale factor is the number you would multiply a length in triangle ABC to get to the corresponding part in PQR. So if we're going from the small triangle to the big triangle, we're going to be multiplying by 3. So the scale factor is 3. The ratio is when we're making a fraction. And on the ratio, we have to set it up like a ratio. It says triangle ABC to PQR. So that means that ABC has to go on the top and PQR has to go on the bottom. The top one, ABC, is a smaller one. So this would be 1, 2, 3. Okay? So the scale factor and the ratio, they're reciprocals. So I'm going to go ahead and type this one in right here. They are reciprocals. Okay. Now going the other way. It says, what's the scale factor from PQR to ABC? Well, now we're going from the big triangle, this is the big triangle, to the little triangle. So we're going to get smaller. So here I would not be multiplying by 3, but I'd be multiplying by 1/3. The ratio, if I have the bigger triangle on top, then the bigger number has to go on the top. So the ratio would be 3 to 1. Part F, what is the mathematical relationship between the scale factor of ABC to PQR? That was the 3. The scale factor of ABC to PQR, that was the 3. And the scale factor of PQR to ABC, well, that was the 1/3. Again, they are reciprocals. What would happen if the image of the scale factor was 1? Well, I know that when I went from small to big, my scale factor, well, I have to multiply by a big number. I have to multiply by something that is greater than 1. If I went from big to small, I had to multiply by something that is smaller than 1. So if the scale factor is just 1, we are keeping the shape the same exact size. The shape stays the same size. All right, moving down. What would happen if the image of the scale factor is bigger than 1? So that's when your shape is getting larger. So the shape goes from small to big. What would happen if the image is less than 1? Well, that's opposite. The shape goes from big to small. All right, next page. All right, this one I'm going to be using a little bit different because I'm on a computer and I'm not on a piece of paper. So I want to make a triangle where the scale factor is 2. So I want to make the triangle twice as big. So what I'm going to do is I'm just going to go ahead and extend these sides with my pencil. I'm going to extend these sides out more than twice as long. And I'm going to extend this side out. That means I just copied the angle. Okay? So where A was is going to be my new D because I see on my thing that A is in the same spot as D. Okay, next I have to make it twice as long. So I need to cut it off twice as long right there. And I need to cut it off twice as long. And then I'm going to connect my sides. Okay, where C was, it's mapping onto F, so we put an F here. And where B was, it's mapping onto E, so we made an E here. And then right here, I have a triangle that is twice as big. So I just copied one, I kept one of my angles and extended the sides. You would also be able to copy down an angle if you're doing it on paper with a protractor, and then make the sides twice as long. That would totally work. Here we go, next one. If the ratio of triangle HIJ to KLM is 4/3, anytime I see that, I actually build the ratio. Okay, so triangle HIJ to triangle KLM is 4/3. Well, which one's the bigger triangle, HIJ or KLM? I see the 4 is with HIJ, so HIJ is actually the bigger triangle. So if I'm trying to make KLM, I know it's going to be smaller. Okay? So here, kind of answered those questions backwards, but that's okay. I need to get to my cursor tool. All right. KLM is the smaller triangle because it lines up with the smaller number in the ratio. Okay, what's the scale factor? So HIJ to KLM. So really, I could think of it as the ratio is going to be the reciprocal, so I know it's 3/4. Or I can also think of it as cross multiplying. So here, over here, I can take this and I can cross multiply, and I'd have 3 times triangle HIJ is equal to 4 times triangle KLM. And then I can solve for triangle HIJ. I can solve for triangle KLM, so I can divide by 4. And I see that I have to multiply triangle HIJ by 3/4 to get to triangle KLM. So I look at my sides before. This was a 4, so now it's going to turn into a 3. So I'm mapping over 3. This was a 1, 2, 3, 4, 5, 6, 7, 8. 8 times 3/4. Well, that is 6. So I'm going up 6. And then I'm going to put my letters down in corresponding parts. So H maps to K, and I maps to L, and J maps to M. So we've got it. Okay, try number 17 and then see if you get the right answer. All right, I saw my word ratio, so I set up a ratio. And then I put the 5/4. BC is coming from the top triangle, so I put the 15 on top. And then I cross multiplied or scaled up. I actually scaled up to get that x is equal to 12. So EF is equal to 12. Triangles below are scaled versions of each other. That means that they are similar. They're proportional. Use a protractor to find the measure of each angle of the 2 triangles. Well, if they're proportional, then they should have the same angle measurements. So go ahead and use your protractor, and then let's check back. All right, so I see that these triangles have the congruent angles. So you should have got congruent angles. That means that one just got enlarged of the other. What is the ratio of ABC to XYZ? All right, well, I need to find 2 corresponding sides that I actually have. The only ones I do have are the 6.4 and the 9.6. I can't use the 8.3 because BC is blank. I can't use the 7.7 because XZ is blank. So I have to pick up my corresponding parts. ABC has to go on the top. So the smaller one's going on the top and the bigger one's going on the bottom. We can't have decimals in my ratios. So I'm going to multiply the top and bottom by 10. That's 64 over 96. That's definitely not reduced. They are both factors of 32. So I'm reducing them. That gives me 2/3. What do you have to multiply the sides of ABC to get to XYZ? Well, here the answer is not 2/3 because I'm not trying to make it smaller. I'm trying to make it bigger. So if I was going from the small triangle to the big triangle, I have to multiply by 3/2. So my scale factor is 3/2. This is called the scale factor. All right. C, you should be able to answer by now because I think I said it like 10 times already in this video. What is the relationship between the ratio, and the scale factor? They are reciprocals. Type it down. What is the ratio of XYZ to ABC? So all they did was flip around the triangle. So I just have to flip around my ratio. So that's going to be 3/2. Okay, next question. Gotta scroll down. What do you have to multiply the sides by? So here we're trying to go from the big triangle to the little triangle. If we're going from the big triangle to the little triangle, we have to multiply by something that's less than 1. So we're multiplying by 2/3. So here we have to multiply by 2/3. Last problem. Okay, last one, number 19. The pair of triangles are given a proportional. Use a proportional to solve the missing sides. So we have to find our corresponding parts. So 5 is lining up with this 2. And I see that the P is lining up with the 7. And I see that the R is lining up with the 8. Now, it doesn't matter if you put the left triangle on the top or the right triangle on the top, but whatever you pick, you have to do it the same every time. So I'm going to go ahead and put the left triangle on top and my right triangle on the bottom. And I'm going to set up my ratios. Okay, so here I had my 5/2. And then I had my P/7. And then I had my R/8. I need to solve these proportions. So I'm going to go ahead and take 2 at a time, always leading with that 5/2, because that's the one I do have for everything. And I'm going to go, okay, 5/2 has to equal to P/7. I could scale up by a factor of 3.5, or I could cross multiply. Most of you would probably cross multiply in doing this one, so I'm going to go ahead and do that. So 2P equals 35. And then I would divide by 2. So I get P's equal to 35/2, which is 17.5. So I know that P is 17.5. These are obviously not drawn to scale. That's okay. Then I'm going to set up my other proportion. I'm going to take that 5/2. We always want to start out with values that we have. 5/2 equals R/8. Now, hopefully, you guys aren't trying to cross multiplying by this, because this is very easy to scale up. I'm just multiplying by 4. And 5 times 4 is 20. So R is equal to 20. So I'm putting in my 20. And then I'm done. Bye, Math A. Go do your homework now.